All right, logic. So a definition first. A statement is a sentence that is either true or false, but it can't be both, and it can't be neither. So we use lowercase letters to denote statements. So we'll have like a lowercase p or q or r. So for example, today is Wednesday, it is snowing, or the moon is green for p, q, and r. And these are perfectly fine statements, all three of them, especially r, the moon is green. It doesn't matter that that's not true. It has a truth value. And so all that we really care about is whether it's true or false. An example that's not a statement. Well, two examples. P, if we say sit down, or is it snowing? So we have a command and then we have a question. So these are not statements. And we can negate the truth of a given statement by using this symbol here. This is the negation of a statement. And basically what that means is we're changing the truth from true to false or from false to true. So for example, if we let P be today is the first day of February, not P would be today is not the first day of February. Or we could even say it is not the case that today is the first day of February. So that symbol right there with the P, that's not P. That's how we say that. And we're going to take multiple statements and combine them. And so we use compound statements. So we need something to actually combine them with. And we do that with what we call operators or connectives. So the two main connectives that we're going to look at, we use a conjunction and a disjunction. So what that means is and or. So let's look at an example. Today is Saturday is P. I go to work is Q. And look at the symbols there. We have this sort of triangle without a bottom for and then we flip that upside down for or. So P and Q, today is Saturday and I go to work. P or Q would be today is Saturday or I go to work. And we could naturally bring in the negations to these. So not P, today is not Saturday, and not Q, I do not go to work. So just as an example, not P and not Q, today is not Saturday, and I do not go to work. And so what we're really interested in are the truth values of compound statements. We want to know if you say two statements to somebody and they're combined by maybe an and or an or, is that a true statement that you just said? And we do that with truth tables. So the truth table for not P here, we have to look at P first. So we know that when P is true, not P is false. And when P is false, not P is true. And so this truth table, the last column, is giving us every possibility of not P, every possibility of the truth value of not P. And we can do that with the compound statements as well. So for example, let's look at P and Q. We want to know when is P and Q going to be true and when it's going to be false, given true or false P and Q. So if P is true and Q is true, that's one possibility. Another possibility is that P is true and Q is false. P is false, Q is true, and they're both false. So here's every single possibility of P and Q being true and false together. And so generally, when we talk about a conjunction, it's only true when both are true. So if we have true and true, P and Q would be true. If we have true and false, so P is true, Q is false, P and Q would be false. P is false, Q is true, P and Q would be false, and if they're both false, P and Q is going to be false. And let's do the same thing for the disjunction. And generally, if we have a disjunction, it's going to be true unless they're both false. So, if P is true, Q is true, P or Q would be true. P is true, Q is false. P or Q will be true. False and true, we'll get a true. And lastly, this is the only time it's going to be false. All right, so there is the truth value of P or Q given every possibility of P and Q. So now we can apply this to other compound statements. Maybe if we just don't have a P or a Q, we might have not P, not Q. We might have 3 statements together. So first here, we're going to keep this off to the side, P and Q, just for reference. And I'm going to change P and Q to A and B because it doesn't really matter the symbol that we use. This first left side here of the and, meaning the left side of the conjunction, is called the antecedent, and the right side is called the consequent. So they're just variables. They're just basically placeholders, A and B. It doesn't actually matter that we're using A or B or P or Q. What matters is what's on the left, what's on the right. So if what's on the left is true, what's on the right is true, then we know that the conjunction will be true. And let's try to look at not P and Q. We want to know what the truth table looks like for not P and Q. So the first thing we're going to do is state every single statement that we're going to need. So we need not P and we need Q, but in order to get to not P, we need P. And then lastly, the last column there is always going to be whatever we're looking for, which in this case is not P and Q. So let's fill it out just like we did before for P and Q, because we already know what that looks like. And now we can fill out not P because it's going to be the opposite of P. So we're going to have false, false, true, true. And this last column is our goal. So the fact that we have not P and Q means that it's going to look a little bit different than it did with just P and Q. So the antecedent is not P, the consequent is Q. So if we look off our table, the antecedent is false, the consequent is true, and when that happens, we get a false, and so we're going to have a false. When the antecedent is false and the consequent is false, we get a false, and so ours is going to be false. When the antecedent is true, the consequent is true, we get a true. And lastly, when the antecedent is true, the consequent is false, we get false. And so we're going to have a false. And so there is our truth table for not P and Q. And again, there's countless variations of this. We can come up with a bunch of different statements for the antecedent and the consequent. And we can even put compound statements within the antecedent and the consequent individually.